Welcome to the math record. Today I'll be covering power series from geometric series. So basically we're going to use the idea from infinite geometric series that we take the summation from k equals 0 to infinity x to the power k. So we plug in k equals 0, k equals 1, k equals 2. We come out as 1 plus x squared, x cubed, etc. So keep going. And we know from infinite geometric series is the first term, which is 1, divided by 1 minus the ratio. Our ratio is x, so 1 minus x. And we also know from infinite geometric series, the radius of convergence has to be 1 because the absolute value of x has to be less than 1. So from there, what we notice is that we could convert functions that look like this into a power series. And that's what we're going to be doing in this video. Let's try an example. So let's say 1 over x plus 5. So the first thing I notice is that if I want to convert this to this, I want x not to be on this side, but on this side. So we have to switch this place. So all we're going to be doing is changing how it looks. So I don't want this to be a positive x, we want it to be a negative x. So 1 over 5 minus negative x. And we don't want this to be a 5, we want it to be a 1, so divide by 5 out. 5 divided by 5 is 1. Negative x divided by 5 is minus negative 1/5 under x. So from here, this looks exactly like this. So this just converted into this, but we got that this gotta look like this. So the only thing different is this, but we could just substitute that x into this. So that's our new x. So we have 1/5 times the summation k equals 0 to infinity. And we have our new x, which is negative 1 over 5x to the power of k. So from there, if we want to simplify this, this is fine by itself, but if you want to simplify it further, you can plug this inside. So k equals 0 to infinity. So negative to the power of k, 1 over 5 to the power of k, plus this 1 over 5. So 1 over 5 power k, plus that additional 1 from outside. And then we have x to the power of k. So this would also be would just be a power series for it, but just with 1, 5 inside rather than outside. And the last thing we have is that the radius of convergence is different now because it's not x anymore. It's negative 1 over 5 x. So since it's absolute value, we keep it positive. So that is just 1 over 5x, absolute value, 1. So that means absolute value of x has to be less than 5. So that means our radius of convergence is not 1, it's 5 for this equation. Okay, let's try another example. So let's say f of x now is x cubed divided by 2 minus x squared. We don't want x cubed, we want 1, so just take it out. We don't want 2, we want 1, so divide by 2. 2 divided by 2 is 1. X squared divided by 2 is 1/2 x squared. So overall, we just converted this into this. So the only thing we need to do is substitute our 1/2 x squared into our x. So we have x cubed 1/2, so 1/2 x cubed, summation, and k equals 0 to infinity. And then we have 1/2 x squared to the power of k. And you could leave it like that if you want, but if you want to fully simplify this, let's kind of delete this because I need room to do the math. Okay, so expanding this out inside first, we have 1/2 x cubed, k equals 0, infinity. So that would be 1/2 power of k times x to the power of 2k, because 2 times k is 2k. So putting those inside, summation k equals 0 to infinity 1/2. So 1 extra plus this k is just 1/2 k plus 1 times x 2k, and we have an x 2k plus the 3, and that is our power series. Or you can use this one or this one, it doesn't matter. They're all the same thing for this power series for this f of x. And as usual, we gotta recalculate our interval of convergence. It's not x anymore, it's 1/2 x squared. So that means square root of x, absolute value x squared is 2. Take the square root of both sides, so absolute value of x has to be less than square root 2. So our new radius of convergence is square root 2. Okay, now let's try one more example, but this time we're going to use derivatives and integrals. So let's say we want to find f of x is equal to, say f of x is equal to the inverse tangent of x. Well, if we take the derivative of f of x, the derivative of the tangent of inverse tangent of x is actually 1 over 1 plus x squared, as I've done before for the inverse derivative for inverse derivatives, which I covered my inverse tangent, and it came out as this. Or you could just search up in Google, and we see that this looks exactly like this. So all we have to do is just rewrite this as 1 over 1 minus negative x squared, and now it matches. So instead of x, we have negative x squared substituted in. So instead of using this form, because this is a derivative, we have to integrate this to get our original. So let's use this form instead. So we have the derivative of f is equal to 1 plus negative x squared, and then plus negative x squared squared plus negative x squared. And this doesn't show it, but it's cubed, and then to the 4th to the 5th, etc. And then etc. So overall, this comes out as 1 minus x squared plus x to the power 4 minus x to the power 6, etc. Now we need to integrate the derivative of f in respect to x to get our f of x originally, because that's what gives us this. That means to get our power series, we just need to integrate this. So we integrate this, the integral of 1 is x, the integral of negative x squared is negative x cubed, the derivative of this is 3x squared, so we need to scale this by 1/3, and then x to the power 5 for x to the power 4. The derivative is 5x4, so we need to scale by 1 over 5. X to the power 6, that's x to the power 7. The derivative is 7x6, so we need to scale by 1 over 7th. And then the pattern continues on. So if we want to write this in summation notation, we notice that if we start from, let's say, k is equal to 1, because this has exponent 1, so I want to start from there to infinity. So we have x, and it's increasing by 2, so let's just say 2, actually start from 0. So 2k plus 1, so then when you plug in 0, that starts with 1. Plug in 1, 2, that makes 3. So we know this number is similar to this, but it's just a reciprocal. So we divide by 2k plus 1 to get that. And we know that the first one is alternating between positive and negative, and the first one is positive. So let's just add a negative 1 to a power and negative 1 to the power of k. Because if you plug in k equals 0, that's positive. Because negative 1 to the power of 0 is 1. Negative 1 to the power of 1 is going to be our negative. So this is going to be the formula. So let me rewrite this because that looks a little bad. So we have negative 1 to the power of k, x to the power of 2k plus 1 divided by 2k plus 1. And that is going to be our equation for our trig. And as usual, let's rewrite our interval of convergence. Our radius of convergence. We substituted negative x squared into our x. So negative x squared into our x is less than 1. Absolute value means x squared is less than 1. And then from here, we could just say that as the value of x is less than 1. So it's still the exact same thing, even though it's inverse tangent. Well, thanks for watching, and in the next video, I'll be covering Taylor and Maclaurin series.